Okay, so here we go. We're going to go further with the closed loop system. And now we're going to talk about the role of auditory and proprioception and its role in the closed loop systems. So its role in motor performance is largely understudied, right? So in this audition and the ability to hear. And what we do know that auditory information is processed much faster than the visual information, but they seem to provide similar information. So the idea is the speed at which that stimuli or that environmental cueing or feedback is received in the system. So the idea of proprioception is really to produce some sort of feedback into the movement aspect or the location of the body in respect to the environment. And so when we look at the vestibular system, we're really talking about these sensors in the inner ear that are really providing a X, Y, and Z axes. And you can see it here with the semicircular canals, the ossicles, and the cochlea. And these are providing that X, Y, and Z. And truly the most important part that we're going to talk about with the X, Y, and Z here are these semicircular canals, because you have your Z, your Y, and your X formed here at the circle. And that's really what is creating this ability for us to move and give us the location of how our head is located in space. And so that idea with the inner ear and the proprioception give us our head motion. And for a lot of people, when you have motion sickness, it's really the inability of these to maintain. And so this creates that ability or that movement pattern that creates motion sickness. And so we look at the labyrinth receptors, and we're not going to go too far in depth with these, but these are all the kind of receptors that you have. And so the idea is that these fluid field spaces are going to bend the hairs, and here you have, right, so the X, the Y, and the Z are going to create this movement on the hairs that provide the information back to the CNS to tell us where we are. And so it really tells us the orientation of the head with relationship to gravity. And it really, the big component for it is this rate and direction of the spin of the head. And so as we rotate around and move through our environment, and that's how you can tell if you're upside down or right side up, because it's this orientation of how the fluids are filling and bending these hairs in relationship to gravity. Now, the two that we most know about as far as proprioception that happen to do within the skeletal muscle system, and those are muscle spindles and GTOs, right? And so muscle spindles are located within the muscle belly, and they're contained in the intrafusal and extrafusal fibers. But the most important thing is this: they are sensitive to the change in length and the rate change of length, so that is position and velocity of the muscle fiber itself. And these are running parallel to the muscle belly. And so as something stretches and how fast it stretches is really the key component here. Whereas the GTOs really are responsive to muscle tension, but not necessarily muscle tension, the tension created within the tendon, because these are located within the Golgi tendon organs. And these are the location where the muscle belly and the fibers meet the tendon. And it's in series with the contractile proteins in the muscle. So really the tension is what's created. And so each of these creates a reflexive response that is sent back to the CNS to tell it, or to other muscles to tell it to contract, to counteract. And then also inhibits the muscle fibers that are located in responding to tell them to stop firing. So now when we talk about how these sensory inputs go back, and then, so it's seen at the central nervous system input, right? And so you have the way that our neuromuscular system interacts, and this is again for some other classes, but just a quick review, is you have a dorsal root and a ventral root. So the dorsal root is your afferent or sensory neurons, and those are the ones that go from the periphery back to the central nervous system, and those are the ones highlighted in the blue here. And then you have the efferent or motor neurons in the ventral root, and those are the ones in the red. So you'll have a sensory input that goes back to the CNS, and then what that response is it either inhibits or excites the motor neurons, and oftentimes the antagonist or the agonist muscles that are going to continue doing that or stop. And these proprioceptors are responsible really for more of an inhibitory component, and where they turn off one and then they go ahead and excite the other, right? But one of the things we'll talk about in this class is these interneurons here in the gray. And that what that does is it bypasses the need to go all the way up to the brain and creates this ability to have a quicker response and more of a reflexive response at this location of the spinal cord that is going to create a faster reaction and inhibition of the motion and more of a safety mechanism. So how does this all play, and how does proprioception play into this idea of a closed loop feedback, right? And so what I have here highlighted, again, and this is the executive level of the information processing, right? So you have the stimulus identification, response selection, and programming, and that's what we covered in previous lectures in the first module. And then you have this reference of correctness, and this is what we talked about previously when this is your reference manager. So this is that idea of you have this blueprint of coming out of your response programming, and it creates that blueprint here in the reference correctness that you think that you, or is the desired outcome of your motion. And then you have this error detection, right? And so the error detection is comprised of each one of these, the muscles, the movement, and these are all the feedbacks, right? So the muscle sensations, and this is your proprioception. The movement sensation, and this can also be some of your proprioception, but it's also a matter of how you felt at the outcome. And then your environmental sensations, where you are in space, and how the movement outcome was. They all come back and feed into this outcome. And then in this location here, you have a measurement that creates, okay, what is happening with the correctness? What happens with the desired outcome? How do we feel? How does the movement feel? And then how did it come in the environment? And that creates your error. Now that error goes back into here, into your executive level again, based on your feedback error. And that's where you create your new motion to either continue doing what you're doing or to change it. And so this is, again, the reference or expected movement outcome and the feedback from a combination of the muscles, movement, and environment feedbacks all produce. And remember that the muscles and some of the movement feedback are where the proprioception occurs. And then the executive level, which is the stimulus identification, response selection, and response programming, you're going to go ahead and make that pattern to either make an adjustment or continue the pattern.